All right, we made it to the last page in the home stretch. All right, 26 says to use two different methods to solve the equations. Um, I've been talking in this review about how if I can factor it, that's my first choice. It feels like the easiest to me. Everything is set equal to 0, so I can consider factoring. It is just an x squared, so it's our easier factoring. Do we have factors of -5 that add up to +4? If we think about our factors of -5, um, we could use a -1 and a +5. Those multiply to -5 and add up to +4. So this is factorable. So in factored form, we'd have x minus 1 times x plus 5 equals 0. We set each factor equal to 0 because of our zero product property. And we get our two solutions. We would add 1 and subtract 5. So x equals 1 and -5. I kind of like this question because it does say to solve with two different methods. So we could complete the square or we could use quadratic formula. I think I'll do quadratic formula just because I know that's a popular choice among students, and I just want to make sure we see how this would simplify with the quadratic formula. So first, our quadratic equation is set equal to 0, so that means we're able to identify the a, b, and c. The last problem, we just did the quadratic formula and wrote it out. So I'm just going to jump right to our x equals negative. Our b is that 4 in front of the x, plus or minus the square root, b squared, so 4 squared, minus 4 ac. So I'm plugging in a 1 for a and a -5 for c, all over 2a. All right, so on the last problem, if you guys were watching the last video, I said that I like to figure out what this number is first. So I know we have a -4 plus or minus the square root of something. And then, like I said, I just grab my calculator. I use all the parentheses that I wrote out when I type it in. So 4, we've got to keep that 4 in parentheses because if it happened to be negative, I don't want you to end up with a wrong answer. And we do all that and we get a 36 all over 2. Now, square root of 36, well, that's a perfect square. Square root of 36 is 6. So we have -4 plus or minus 6 all over 2. We will keep simplifying because the -4 and the 6 are like terms, so we can continue to simplify this. We'll just break this apart. One of them will use the addition, -4 plus 6 all over 2. -4 plus 6 is +2. 2 divided by 2 is 1. And I can see we got a 1 over here, so that's looking good. And then now we have to do, with that plus or minus 6, we have to do -4 minus 6 all over 2. -4 minus 6 is -10. -10 divided by 2 is -5. And I can see we got a -5 with the other method as well. So I like this question just because it's showing how we can get the same answer and we have different methods. Sometimes one method might be easier to solve than another method, and you can kind of choose the method that feels easiest. All right, our next couple problems says describe the solutions as one real, two real, or two imaginary solutions. So when we have to describe the solutions, they're not asking us to find the solutions. They just want to know, um, about the solutions. How many do you have and what type are they? Are they real or imaginary? So this is the discriminant. The discriminant is the b squared minus 4ac. It's that number that we square root. That's underneath the square root of your quadratic formula. So when b squared minus 4ac, if that number is greater than 0, that means it's positive, you're going to have two real solutions. b squared minus 4ac, what if it's negative, less than 0? You're going to have two imaginary solutions. And then what if b squared minus 4ac is equal to 0 exactly, like right on the money, equal to 0? That means you're going to have one real solution. So what we have to do is figure out the discriminant. We're just going to do b squared minus 4ac and see if it's positive, negative, or equal to 0 to tell us about our solutions. You do need to make sure that your equation is set equal to 0, so we're good here for both of these actually. They're equal to 0. That's when you identify your a, b, and c. So we're going to do b squared minus 4ac. So our b value is negative 15 squared. Notice I'm using my parentheses. Minus 4 times a, which is 1, times c, which is 12. Negative 15 squared is 225. Well, actually, just so we don't get confused, if you're using your parentheses, just type that in. Negative 15 squared minus 4, use all those parentheses, and we get 177. So 177 is the discriminant. That is not the solution, but is 177 greater than 0, less than 0, or equal to 0? Well, this 177 is greater than 0, so this quadratic equation has two real solutions. So the math is not hard to do on these. You're really just doing b squared minus 4ac, but we do have to understand and know this part over here. The way that I remember it is I recognize that b squared minus 4ac in the quadratic formula is underneath a square root. So if you think about it, if b squared minus 4ac is greater than 0, if it's positive, so let's just think, if you're square rooting a positive number, you can square root that, right? Mathematically, you get real solutions. And with the plus or minus built in front of that square root, that's how you're getting two real solutions, because you can square root a positive number. Now, what if what you're square rooting is less than 0? B squared minus 4ac, if that's less than 0, that means it's a negative number. Well, when you square root negative numbers, it's imaginary. So you have imaginary solutions. But again, the plus or minus is built into the quadratic formula, and that's how we're getting two, the positive and the negative imaginary solutions. And then the last thing is, what if you are square rooting, what if your b squared minus 4ac is equal to 0? Exactly. You still have your plus or minus out front, but what is the square root of 0? Square root of 0 is 0. Can you have a positive 0 and a negative 0 to give us two different solutions? No, that's why you can only have one solution, and it is real because we are able to square root the 0. So this little part right here, honestly, that's the way my brain makes sense of all of this over here. So hopefully something that we've talked about right here is helpful for you. All right, so number 28, we got to find the discriminant. We have to do b squared minus 4ac. So again, parentheses, here's my b squared, negative 6 squared, minus 4 times a, which is 3, times c, which is 4. And then you're allowed to use your calculator only if you promise me that you will use all those parentheses. So negative 6 squared minus 4 times 3 times 4. Some real time typing this in for you guys. Okay, that is a negative 12. So our discriminant, our b squared minus 4ac is negative. It's less than 0. That means we will have two imaginary solutions. And this stuff in the middle, all of this is just me kind of explaining how I remember this part over here. All right, last question. It says, find the values of k that will cause this equation to have no real solutions, one real solution, or two real solutions. Okay, so we're gonna do three things here. I think a similar question in the test would only ask for one of these, but we'll just cover all of them. So we want our equation to have no real solutions. Well, if it has no real solutions, that means that there are two imaginary solutions. All right, so our b squared minus 4ac is less than 0 when we have two imaginary solutions. So this is what I'm going to set up, b squared minus 4ac. If I look at the equation up here, k is my b value. So I'm going to replace b with k. So we have k squared minus 4 times our a is 4 and our c is 4. And that is less than 0. So we're just going to solve. K squared minus 4 times 4 times 4 is 64. And we're just solving for k. So k squared is less than 64. Square root both sides. So k will be less than a positive and a negative 8. All right, well, what if they ask us for one real solution? What value of k would give us one real solution? Well, one real solution happens when b squared minus 4ac is equal to 0 exactly. So I'm going to plug in all the same numbers, b squared minus 4ac, which we did over here. So I know it's going to give me this k squared minus 64. So if you guys are okay with that, I'm just going to jump to that because do you guys see b squared minus 4ac? Same thing. I just plugged in the k and the 4s, and instead of less than 0, it's going to be equal to 0. So I'm going to add 64 to both sides. So k squared is equal to 64. We square root, so k has to equal exactly a positive and a negative 8. Those are the values of k that would produce one real solution. All right, last one. What if we wanted two real solutions? Well, two real solutions happen when b squared minus 4ac is positive, so greater than 0. So we'll go ahead and plug in our a, b, and c, just like we did right here. So I know I'm going to end up with a k squared minus 64. So if you guys are okay with it, I'm just going to jump to that. And then we solve for k. Add 64. K squared is greater than 64. Square root both sides. So k is greater than a positive and a negative 8. So that's how we'll get those three answers. Those are all values of k that would cause this equation to have those three possible outcomes.